Hello everyone, myself Saloni Tiwari of PSC second year Maths Regular, and I am here to explain you the topic related to the mechanics which we study in fourth semester. So the topic is, what is equilibrium? A body is said to be in translately equilibrium if the net force acting on the body is zero. That is, here you can see the net force, that is F net is equal to 0. Now if the force are conservative, now there are two types of forces now, that is the conservative and non-conservative. So if they are conservative forces, then F is equal to minus cut du by dr. So and for conservative the force is 0, so minus cut du by dr is equal to 0, or the negative can be neglected, as the on the right hand side it's 0 only, so it can be written as du by dr is equal to 0. Now at equilibrium position, the slope of ur graph is 0, or the potential energy is optimum, maximum, or minimum, or constant. It can be any. So now we'll study the general conditions for the stability of body resting on another one. If the upper body has a plane face in contact with the lower body, then R is infinite, so we have a stable equilibrium, and for that H must be less than R. And for unstable equilibrium, H must be greater than R. Now if the lower body is a plane surface, then R is equal to infinite. So we have a stable equilibrium for for H less than R, and unstable equilibrium for H greater than R. The third point is, if the lower surface is concave, then R is negative, and we have the stable equilibrium for 1 upon H greater than 1 upon R minus 1 upon capital R, and for unstable equilibrium we have 1 upon H less than 1 upon R minus 1 upon capital R. So this was the general conditions for the stability of a body resting on another plane. Now as we proceed forward, now we'll study for the types of equilibrium. What are the types of equilibrium? Generally we have three types of equilibrium: stable equilibrium, unstable equilibrium, and the neutral equilibrium. What is stable equilibrium? Stable equilibrium में क्या है कि when a particle is slightly displaced from the equilibrium and it tends to come back towards the equilibrium, then it is said to be in stable equilibrium. Now, unstable equilibrium, when a particle is displaced from the equilibrium and it tends to move from the equilibrium position, then it is said to be in unstable equilibrium. Now, the neutral equilibrium. When a particle is displaced from the equilibrium and no force acts on it, then the equilibrium is said to be as neutral equilibrium. The situation where F is equal to 0 and du by dr is equal to 0 can be obtained under three conditions: stable, the diagram for the stable is this one; unstable equilibrium, the diagram for the unstable equilibrium is here; and the neutral equilibrium. So these are the three equilibrium: stable, unstable, and the neutral one. Now let us proceed towards applications of theory of equilibrium on a string. Now equilibrium of string. If the weight per unit length of the change or the string is constant, the catenary is called the uniform or the common catenary. Now the equation of common catenary. Before that, you must consider that the string should be flexible and inextensible, that is, which offer no resistance to bending at any point. So it should be flexible and inextensible. When a uniform string or chain hangs freely between 2 points, or in this 2 points not in the same vertical line, then the curve in which it hangs under the action of gravity is called common catenary. So this is what is common catenary is. Catenary is, now the distance AB is called span. This one distance AB is called span. CD is sag in the middle. This CD is sag in the middle. The arc CP, this one, the arc CP is S, and OC is C. OC is C, and the weight per unit length is W. Now let ACB be the string of which the lowest point is C. The lowest point is C. P is any point on the string such that the length of the arc CP is equal to S. Now let T be the tension at point P and psi its inclination to the horizontal. At lowest point, C, the tension is horizontal and let it be T naught, this T naught. Now let W be the weight per unit length as already told, and linear density of the string which is constant throughout as the string is uniform. Then the portion Cp of the string, this one, Cp of the string is in equilibrium under the action of forces which are the tension T at P and T naught at C. The weight W is acting along a vertical line passing through the CG of the portion Cp and through the point where the two tensions meet. All these three forces will meet at one point for the string to be in equilibrium. Resolving these forces horizontally and vertically, what we get is T is equal to T naught is equal to T cos psi and Ws is equal to T sin psi. So here it is written, which I have told you. Now let us suppose that the tension at the lowest point is equal to the weight of the length C of the string, so that this T naught is equal to Wc, T cos psi is equal to Wc. Now from first and second equation we get tan psi is equal to S upon C, so S is equal to C tan psi. Now we'll study about the system of force and its type. A force system is a collection of force acting on a specified location, and thus the force of system shown on any free body diagram makes a force system. Now what are the types of force system? Coplanar and non-coplanar force system. The force system in which all the forces are acting on the same plane is known as coplanar, whereas in different planes are known as non-coplanar. The diagram is here. Now, the concurrent and non-concurrent system. The forces are passing through a common point are called concurrent, and those which are not passing through the common point are called non-concurrent. Here is the diagram. Now, what is Poinson's central axis? A system of forces acting at different points of a rigid body B reduced to single force of magnitude R acting along a line and a single couple of moment G cos theta about the same line. This same line is called Poinson's central line. There are some definitions that we must have a view over that. The first one is the central axis. Central axis, in this we see that if a system of forces reduced to single force and a single couple in such a way that the axis of the couple coincides with the line of action of force, then the line is called central axis. Now the next one is, what is wrench? If a system of force is reduced to single force R and couple having K whose axis coincides with the direction of force, then R, K is called the wrench of the system. Here R is called the intensity of wrench and the ratio K upon R is called pitch of the system. And for the pitch of the system, the P defined is known as the pitch of the wrench, and thus by taking the dot product of both the sides of equation G is equal to PR, with capital R we have R dot G is equal to P R dot R, or it can be written as P is equal to R dot G upon R square, but at R, that is X, Y and Z, and G, that is L, M and N, where the symbols have their usual meaning. Thus the conclusion is that P, the pitch, is equal to Lx plus My plus Nz is equal upon X square plus Y square plus Z square. Now what is screw? What is screw? A screw is a straight line along, when considered together with the pitch is known as screw. So this was all about my presentation. Hope you all guys like it, and thank you for listening me.